Okay, geometry, this is the last section of chapter 10. This is surface area and volume. So this note sheet, I want you to flip over to the back side first. This is my second time recording this video. The first time didn't save, so let's hope this one does. Surface area and volume, they have the three-dimensional figures here that we've talked about earlier in this class. So prisms, pyramids, cylinder, cone, sphere, each one of those. And they have the surface area and volume for each. So I want to kind of go through some of these. I will not, or I do not expect you to have these formulas memorized. In fact, on the ACT, they will ask you questions like this. So they ask you like to find the surface area of this cylinder, but they will usually always give you the equation for it. You just have to kind of know how to do it and how to plug it in, okay, and know what each one of the variables mean. So that's kind of what I want you to get out of this section. For some reason, T, they represent as total surface area. So what I'm going to do is I'm going to go through and change all of these T's to SAs because T doesn't really make a whole lot of sense to me. You can leave it as T if you want to, but I'm going to change them to surface area. And then they have the equation for volume of each one. Okay, so T is surface area and V is volume. And then they have capital P and capital B. So let's talk about what those guys mean. Capital B, like in this equation up here, is the perimeter of the base. Okay, so if I'm looking at this prism here, the base is the bottom in this case. It won't always be the bottom, but if I'm finding the perimeter of the bottom, I would just add all those together. Okay, here is the perimeter of my base. I would add all those four sides together. Okay. Then I have capital B, which is the area of the base. So when they use capital letters, they're kind of referring to base here. Capital P is perimeter of the base, capital B is area of the base. So to find the area of that base, I would just take base times height because that's a rectangle. Same thing here. It's a rectangle or a square, base times height to find the area of the base. H is height, okay? And L is slant height. So let's talk about the difference between those two. In a cone and in a pyramid, you will have a height and then you have a slant height, okay? So the height is going to be straight down. Perpendicular with the base. Okay, this guy's height would be like from here straight down to the center of that pyramid, kind of like driving that pole down the center. And the slanted height is this one right here. Okay, so the slanted height might be this guy here, or they'll represent it like on the front side of the figure as a slant height. But there's a difference between those two, so don't get those confused. And then R is going to be the radius. So a sphere and a cylinder will have radius lengths that you'll need to know for their surface area and volume formulas. Okay, so what I'm going to do is some of these problems I'm going to have you do on your own, where I'm not going to do all 8 of them with you. I'll do maybe like 4 of them or so, but we're going to go back and forth to this formula chart over here, the one that we just went through. So I don't have to flip back and forth. I'm just going to click onto this guy and then we'll get our formula straight off of there. Okay. So starting with example 1, they want us to find the surface area and volume. Okay, so I'm going to do surface area here, and maybe we'll do volume down here. It's usually the case that the volume is a shorter formula than surface area. Surface area of this guy. Now let's decide what this thing is. They tell us it's a prism, but from a couple chapters ago when we talked about prisms, prisms will have 2 bases that are parallel to each other. And in this case, the base is going to be this triangle here and this triangle here. So the base is not technically the bottom in this figure. It's actually these 2 sides. And the height is going to be this 7. So even though the height is kind of the length in this case, think of this as if it were sitting upright. Okay. So the base is going to be the 2 triangles. The height is going to be 7. So maybe we do that. I'm going to do height equals 7. The base is that bottom side. Let's go ahead and write our formulas in here for surface area and volume of a prism. Okay, so even though this is a triangular prism, it's going to have the same formula down here. Okay, so T, or surface area, is going to be capital P H plus 2 capital B. That's the surface area. Volume is capital B times H. Okay, so out of these equations right here, okay, I need to know H, I need to know what capital B is also, and then I need to know what capital P is. Okay, so I'm going to list those off to the side over here, and let's figure out what those are. So the H is just this height right here. Okay, we've already said that. The base is the area of the base. Capital B is the area of the base. And we said that this base is the triangle. Okay, so if we're trying to find the area of that triangle, we would do area equals 1/2 base times height. That's the formula for area of a triangle. And in this case, the base of that triangle is going to be 6, and the height is going to be 5. Okay, so I have 1/2 6 times 5. Half of 6 is 3, and 3 times 5 is 15. So I have the area of my base is 15. All right, so I'm listing these off to the side over here, and then I can just plug them into these two equations. Okay, now the problem is perimeter. If I'm trying to find the perimeter of this base, I need to know all 3 of those sides. Okay, so I know that the bottom is 6. This guy is 5, but I don't know what this is. Okay, I don't know that third side. But since this is a right triangle, I can use the Pythagorean theorem to find that. Okay, so using the Pythagorean theorem, 6, 5, and this third side, let's do 6 squared plus 5 squared equals, we'll call that side C, C squared, okay? Or 36 plus 25 equals C squared. If I add those two together, 36 plus 25, I can do that in my head, that's I think like 61 equals C squared. And then I would take the square root of 61, okay? So I'm gonna have the calculator do that for me. I have the square root of 61, and that third side is 7.8. 7.8 is that third side. Okay, so we're still working on finding the perimeter, adding those 3 sides together. So 7.8 plus 6 plus 5 is what I want for my perimeter, those 3 sides. Okay, 7.8 plus 6 plus 5. Okay, I add all 3 of those together, and I get 18.8 as my perimeter. Okay. All right, so now that I know all of my variables that I'm going to need for both of these equations, I'm just going to go ahead and plop stuff in. Okay. So the perimeter of the base, we said, was 18.8. The height was 7 plus 2 times capital B is 15. Okay. Now I can try to do some of this stuff in my head, like I know 2 times 15 is 30. So the rest of it I'm going to type in. Let's see what we get here. Okay, I have 18.8 times 7. Okay, enter. And then I'm going to add 30 to that. So I get 161.6. 161.6, and that, my units are in centimeters. And since we're doing surface area, that's centimeters squared. Okay, so all of these faces, each one of those faces, if I add them together, is going to have an area of 161.6. Okay, now volume, if I'm just doing the area of the base, you know the area of the base is 15, the height is 7, I would just take 15 times 7, and that would give me my volume. 15 times 7, okay, is 105, and that one is in centimeters, and when we're dealing with volume, we're in centimeters cubed. Okay, so that's what his volume is going to be. All right, so surface area volume, not too hard, just you have to make sure that your formulas are really clear and you're plugging it into your calculator properly, okay? Example 2, I'm going to have you guys do this one, so I'll post that question here in just a second, but let's go through and I'll help you kind of draw what this thing looks like. The marketing department of a shoe manufacturer is designing what will be printed on the boxes, so on the shoe boxes. Each box is a rectangular prism with a base of 6 by 14 and a height of 5. Okay, so I'm going to draw this box here. Let's do this. And I draw boxes all the time, so if you're wondering, how the heck do you draw them like that? Well, that's because I've been doing this forever. I should do dotted lines in the back. There we go. Okay, so it is 6 by 14 and 5 units tall. That's what he will look like. Okay, so here's the front of my box, the bottom of my box, etc. Right? Okay. So what I'm going to have you do is I'm just going to have you find the volume of the box. Don't worry about finding the surface area. That's what you're going to do in the question. So use the formula and do the best you can to find the volume of that. Okay? All right, example 3, if we're finding the surface area and volume, I'll do that down here, of a cylinder, surface area volume. Let's go to here and see what we need for surface area volume of a cylinder. Surface area is 2 pi RH, so 2 times pi times the radius times the height, plus 2 pi r squared. Just copying this guy down. volume is pi radius squared times the height. Okay. All right, so the things that I need, the only variables that I have in here are the radius and the height. So I just need to use my figure here to figure out what the radius and the height are. So let's do with the height first. This cylinder is laying on its side. It's like the soup can has been tipped over. So the height is technically 18 in this case, okay? The radius is only half of this distance, right? The radius of a circle is only from the center to the outside. So the whole length is 15, the radius is going to be 7.5. I divide that by 2, 7.5. All right, now I can just go ahead and plug stuff in. So 2 times pi, the radius is 7.5, height is 18, plus 2 times pi times 7.5 squared, okay? So what I'm going to do is, because there's a plus sign here, I'm going to separate those out into two pieces so I have less to enter into my calculator. Because then I'll hopefully, have less chance of making a mistake in that case. So what I'm going to start by doing is this first part. 2 times pi times 7.5 times 18. Okay, I should just be able to type that all in one shot. And I get 848.2. Okay, then I'm going to go 2 times pi times 7.5 squared. And that gives me 353.4. Okay, and then if I add those together, 353.4, I could have just left that in my calculator, but that's okay. 848.2, if I add those together, I get 1201.6. So 1201.6, and that is in millimeters, and surface area is squared, okay? So a lot of what this is just making sure that you know how to plug it into your calculator, you know what R and H are, you know how to find them, that type of thing. Okay, volume, if we write all this stuff in here, pi times 7.5 squared times the height is 18. So let's try and plug that in. Pi times 7.5 squared times 18. 3180.9. 3180.9, and that is in millimeters cubed, because that's what volume is, okay? Now, in this case, my volume was larger than my surface area, which is what happens in most cases, but it's not necessarily true that your volume will always be larger than your surface area. For example, in example one, we had that our volume was 105 and our surface area is 161. So it just kind of depends on what your figure looks like, you know, to which one is bigger. So don't always go by that, okay? All right, I'm going to have you do example 4. So this is a pyramid, and I want you to find just the surface area. So don't find the volume. But it says that this is a square pyramid. Okay, that means the bottom is a square. Here's what he's going to look like. My bottom guy is a square. Something of that nature. Okay, don't spend too much time trying to draw the thing. But there's my figure, and its slant height is 10 inches, and the base is 12 inches. Okay, but since it says that it's a square pyramid, I know that this length is 12 and this length is also 12. Okay, so just find the surface area, and I'll have you do that question now. All right, let's move on to example 5. And they want just the surface area of this cone. Okay, so this cone right here, let's go to our formula for surface area. Surface area of a cone, we need pi times the radius times the slant height plus pi times the radius squared is what we need. Okay, so in our formula, the two variables that we have are R and L, which is the slanted height. Okay. And then, so from this information here, we need to know what the radius is and the slanted height is. So slant height is going to be this distance here, which is 15, and the radius again only goes from here out. So it's only going to be half of that. Think about in your head, what's half of 14.8? Half of 14 is 7. Half of 8 is 0.4. Okay, so 7.4 is my radius, and now I just plug in. So pi times 7.4 times the slant height is 15. Plus pi times 7.4 squared. Okay, all right, and I'm going to just type this first part in, just type the second part in, and we'll see what we get. Okay, so pi times 7.4 times 15, that first part, I get 348.7. Second part, pi times 7.4 squared is 172.0. Okay, all right, so doing those in pieces kind of helps me a little bit so that I don't make a mistake typing stuff in. 348.7 added to 172.0, or just 172, is 520.7. Okay, so the area of all of those surfaces all the way around is 520.7 centimeters squared, because that's, we're doing surface area. Okay, all right, on the back side, I'm going to skip the top example because it's just another cone and cylinder problem. I'm going to have you do example 7 or try example 7 on your own. They just want the surface area of this sphere, okay? And you have the equation for surface area of a sphere, 4 pi radius squared, okay? So you try to do that, attempt that on your own and see what you get. I'm going to go ahead and do example 8. So surface area of this hemisphere, okay? So this one's a little bit trickier. If we're doing the surface area of a sphere, just like the one that you just did, was 4 pi radius squared, but since we're doing a hemisphere, that's only half of it. So I'm going to take that guy and I'm going to divide him by 2 to get just this hemisphere. Okay, so what I can do then is 4 divided by 2 is just 2, so I'm only doing 2 pi radius squared in that case. Okay, and then there's one more thing that we kind of have to do at the end, so I'll show you that. But we need 2 pi radius squared. The radius is 2.8 in this case. So 2 times pi times 2.8 squared. And let's plug that in and see what we get. 2 pi, well, you can either do 2 pi or 2 times pi. It doesn't really matter. 2 times pi times 2.8 squared. And I got 49.3. 49.3 in this case. Okay, now, here's the tricky part. When you're finding surface area of a hemisphere, 49.3 will give you this top like area all the way around that top cone part. But since we've taken this a sphere and we've lumped him off in the middle, now we also have another surface that's exposed, which is on the bottom. Okay, that's not accounted for. So we've accounted for the top part, but we haven't accounted for the surface on the bottom that we need. So the surface on the bottom needs to be added to the 49.3. Okay, so if you think about what the surface on the bottom is, if I just turn that and look at that shape, that will just be a circle on the bottom. So we just need to add in the area of that circle. Okay, and the area of a circle is pi radius squared. Okay, so I would just take pi times 2.8 squared. Pi times 2.8 squared. Okay, so I'm going to take a chance. I'm going to leave the 49.3 in my calculator and just add pi times 2.8 squared. If I just do it that way, then it will give me the correct answer. And I have 73.9 is going to be my surface area. And that's in centimeters squared, because area squared. Okay. So sometimes you might have to do some tricky things and add on. Just think about what your equation is saying and add on if there's, you know, a hemisphere or parts missing or parts added. And there we go.